Hello and welcome to this video. We're going to learn how to integrate the natural log squared of x, or simply ln squared x. Remember, during the previous video we learned how to integrate the natural log of x, and we used integration by parts to work out the integral of the natural log of x. And now in this video we are still going to use the same concept, that is integration by parts, to work out the integral of the natural log squared of x. And so let me write down the formula for integration by parts. So if we have the integral of u dv, so this is going to be uv minus the integral of v du. Okay, so that is the formula for integration by parts. So this means that we have to identify from here, we need to identify u, we need to identify dv, and after we have identified that, we need to find the value of dv, and we also need to find not dv but du, and we need to get the value of v. So now we have a coefficient 1 here. Let me use a different color. There is a coefficient 1 here. So as you know, if there is no any figure indicated, this means that the coefficient is 1, and the value, and this means that the value of u is going to be ln squared of x. We are going to use ln squared of x as the value of u, and dv is going to be 1. We are going to use 1 as the value of dv. So instead of just writing 1 dx, we can simply write it as dx. Okay, and so now we need to evaluate the value of du and also the value of v. Okay, so let's start by finding the value of du. Du simply means that we're going to find the derivative of u, which is ln squared. So to evaluate the derivative of ln squared, we're going to do this by using the chain rule. Okay, I know that we have not covered the chain rule, but I'm just going to introduce just a bit so that we can get to solve this question or example, but I will create more videos about the chain rule for derivatives, so that we can get to understand in a better way. So the chain rule is used to find the derivative of functions that are, or rather functions that involve smaller functions inside larger function. What do I mean by this? That smaller functions inside larger functions. Now for this case we have ln squared of x. Now ln squared of x can simply be written as ln x squared. Okay, ln x squared. This is the same thing as this. So we have a smaller function here, which is ln x, inside a larger function. So when we put this squared up here, this is the larger function, and then the smaller function is, or the inner function is ln x. Okay, so let me write the general formula for the chain rule. So if we have a function, let's call it a, okay, let me call it that way, a raised to n, but both of these are functions. A is a smaller function inside another function, we can use the chain rule to find the derivative of this function, and the formula is going to be n a raised to n minus 1, okay, raised to n minus 1, and then we multiply by the derivative of a. So let me have a prime. So a prime is the derivative of a. So for this case, a represents ln x and n represents 2. So let's try to work out this. So this is going to be, so we have the value of n as 2, so we're going to have 2, and then the value of a is ln x, so we have 2 multiplied by ln x raised, so we're going to have n, which is 2 minus 1, so we have ln x raised to the power of 1, so that remains the way it is. So it's still going to remain as ln x, because anything raised to the power of 1 remains the same, and then we multiply by the derivative of a. So the derivative of a, and we know that a is ln x, so the derivative of ln x is actually 1 over x. Okay, so this is going to be 2 over x. Okay, so I've just moved at this x here, so we have 2 all over x and then ln x. Okay, so once you simplify this, it's going to be 2 over x ln x dx. Remember, this is now the value of du, so we can you can put it up here. So we have 2 over x ln x dx. So that is the value of du, and then the value of v is going to be the integral of dx, which is simply going to be x. Alright, so we have now found out the value of du and the value of v. So we are now going to replace these values to this integration by parts formula, so that we can now proceed. So we have okay, so we have, so let's replace these values up here. So we have the value of u. Okay, the value of u we have found out to be, okay, ln x ln squared x, and then the value of v is actually x, so we're going to multiply by x, and then minus the integral of v, which is x du. Okay, and du for this case is 2 all over x ln x dx. Okay, so let's work out this. So when we multiply this, it's going to be x ln squared x minus, so this x will cancel out with that x, so that we are left with the integral of 2 ln x dx. Okay, so let's work out this. We can put okay, or rather let me write it afresh. So we have x ln squared x minus, so we can put these two here, so that we have that way ln x, so that we now find the integral of ln x. Now remember, during the previous video we learned how to work out this, and if you never happened to watch that video, you can check it out via the link that is in the description box. So let's work out this. So we are still going to use integration by parts to work out the natural log of x. So the value of u here is going to be ln x, and the value of dv is going to be 1 dx. Remember, we have 1 here, so the value of dv is going to be 1 dx, which is equal to dx. So du is going to be the derivative of ln x, which is 1 over x, and then the value of v is going to be the integral of dx, which is going to be x. So we are still going to use integration by parts to work out this. So let me replace these values to the integration by parts formula, which I had written up here. So I don't need to write it again. So we're going to have uv. Now the value of u here, the value of u is ln x. So we're going to have u, which is ln x, multiplied by v, which is x, and then minus the integral of v du. So we have v as x and du as 1 all over x dx. Okay, remember we have dx here. I'm sorry for that. So we have, so this is going to be x ln x minus, so when this cancels out, we're going to have the integral of 1 dx, which is simply the integral of dx. So this is going to be x ln x minus the minus x. Okay, so let's replace this. Now remember, this was the integral of ln x, so we need to replace it up here so that we have, okay, let me write it down here, so that we have x ln squared x. So now this is the final answer, x ln squared x minus 2. Remember, we have a 2, so 2 multiplied by the whole of this minus 2 multiplied by the whole of this thing. So we have 2 multiplied by x ln x minus x, and then remember a plus c, which is the integration constant. So let me check out whether we can simplify it further. Alright, we can. Okay, so we have x ln x. Now for this one we can put okay, oh yes, I can see we have x is common for that case, for this one and even for this one. So we can have so we can actually put x outside the bracket, so that we have ln squared of x minus 2 ln x minus 2, okay, and then a plus c, and that, oh, I'm sorry, this should be a plus, this should be a plus 2. I'm sorry for that, because we have negative 2 times negative x, so this should be a plus. So, and that is the integral of ln squared x.